we're going to talk about Lewis dot diagrams. That's why I'm here today in my kitchen, not shaved, feeling a little greasy. Got my Alabama hat on and bacon, two of the best things in the world. So anyway, let's get to it. If you remember these rules from before, I just want to remind you what these rules are. I'm just going to show you how to do 2 or 3 of these. And this is in case you didn't get it in class. There's, you have this is how you do it. So this is more of a review thing, not you have to watch it. All right, so Lewis dot structures. What you want to do, let's pick one. So let's say CH4. First thing, if you remember, you might want to go back and look at your steps. How many total electrons are there? Carbon is in group 14, so it has 4 valence electrons. And hydrogen has 1 valence electron, so that's a total of 4 more. That's a total of 8. So you have 8 electrons to spend. Next step, least electronegative in the center. Now there is a little bit of a caveat to this. Hydrogen can never go in the middle. Hydrogen always has to be out on an edge. It can only form 1 bond. So I'm going to go ahead and put carbon in the middle. And I'm just going to put the hydrogens around it. It doesn't have to be in any certain form. It doesn't have to be in any certain shape or anything like that. I'm just going to kind of space them out. It's unimportant at this point exactly where you put them. The geometry comes later. I've got carbon in the middle, everybody else around it. Hook everybody together with single bonds and give the outer elements 8 or make them happy if need be. I'm going to hook everybody together with single bonds. Single bond, single bond, single bond, single bond. Realize every single bond represents 2 electrons. 2 electrons being shared. There's 2, 4, 6, 8 total. I have used all 8 electrons, therefore I am done. I can't spend any more than I have, and I have to spend all that I have. So you can't just say, I got 2 left over or anything like that. So that's a pretty simple one. 2, 4, 6, 8. Carbon sees 8. Each hydrogen sees 2. That's exactly what we wanted. A little bit harder one. Not super hard, but a little bit harder anyway. H2O. How many total electrons do we have? We have 2 from hydrogen. 6 more from oxygen is equal to 8. Put the least electronegative one in the middle. That would be hydrogen, only it can't be hydrogen, so oxygen in the middle, hydrogen just on either side. Next step, hook them together with single bonds. Single bond, single bond. That's 2, 4. It says to make anybody on the outside happy first, which the hydrogens are happy, I don't have to worry about it. Use anything left over around the central atom. So I've got 2 here, 2 here. I need a lone pair here and a lone pair there. That's a total of 2, 4, 6, 8. I had 8 electrons. Therefore, the electron dot structure of this puppy is HOH. Lone pair, lone pair. So that's how you do that one. All right, let's pick something a little bit harder. Let's pick something without H. HCN, hydrocyanic acid. So something with H. But figure out how many you got. Hydrogen's got 1. Hydrogen's got 1 electrons. Carbon has 4 valence electrons. Nitrogen has 5 valence electrons. Add them all up, and what do you get? You get 10. Least electronegative in the center. Who's the least electronegative? Carbon. You can look it up on your periodic table. Then the hydrogen and the nitrogen go on either side. Hook everybody together with single bonds. Single bond, single bond. That's 4, right? So I started out with 10. I lost 4 from my bonds. So from here and from here, that was a total of 4. Now it says to use lone pairs to make anybody happy on the outside. Well, hydrogen's happy. Nitrogen, though, is not. It sees 2. It needs 6 more. 2, 3, 4, 5, 6. So minus 6 more is a total of 10. Okay, I've spent all my electrons. The last step says move electrons around if need be. The problem with what I have right now in this thing is nitrogen's happy, carbon is not. So I can feel free to move any lone pair that I've got to make a double or triple bond if I want to. So let me move one of them. I'm going to move one lone pair from the nitrogen to the bond area and make a double bond. Now I only have two lone pairs, and I move the other one to that double bond. Now hydrogen sees 2, it's happy. Carbon sees 2, 4, 6. There's 2 electrons here, 4 electrons here. That's 2 plus 4 more is 6. Carbon is not happy. Nitrogen sees 2, 4, 6, 8. Nitrogen is happy. So carbon's not happy, nitrogen is. Let me try one more time, see if I can fix it. I'm going to move one more lone pair over here. See if that makes things any better. I'm going to move it to a triple bond and have one lone pair left over. Now carbon sees 2, 4, 6, 8. Nitrogen sees 2, 4, 6, 8. Hydrogen sees 2. That means this guy is very, 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 very happy. We'll do one more. Carbon dioxide, that's a good one. So how many does carbon have? Carbon has 4. How many does oxygen have? Each oxygen has 6. That's a total of 12. Makes for a total of 16 electrons. Who goes in the middle? The least electronegative, that would be carbon. Who goes on the outside? The other guys. Remember, it's like one guy in the center, everybody else around him like spokes on a wheel. You wouldn't have C, O, and then O. Okay, that is not right. You want it set up like that. Everybody gets single bonds. So I've spent 2 electrons here, 2 electrons there, so I've spent 4. Take anything I have left over and put it around the outside, guys, so the oxygen, not the carbon. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, notice I had 12 electrons left over, and I used all 12 of those to make the oxygens happy. So I took away 12, leaving me with 0. Is this right? Well, the oxygen's happy. This oxygen's happy. Sees 8. Everybody wants 8. Carbon, on the other hand, only sees 4, 2, 4. So what can we do? Well, we can move electrons around to make it happy. So let me try this. I'm going to move one lone pair from each oxygen to a double bond. There's the first one. There's the second one. And now oxygen sees 8, oxygen sees 8, carbon sees 8. Everybody's happy. So this is the electron dot structure for carbon dioxide.